All right, so we are given that we have a beach. It has a slope of 10 degrees. It has waves coming into it that have a period of 6 seconds, a deep water wave height of 3 feet, and then it asks us to find the surf similarity parameter for the waves, and then also what kind of breakers are going to happen at that beach. All right, we're going to go ahead. The first thing we're going to do is we're going to solve for the deep water wavelength. So that's going to be g times t squared over 2 pi, which is going to be 32.2 feet per second squared times, not 10 seconds, times 6 seconds squared, all divided by 2 pi. If we plug that in, we get a deep water wavelength of 184.5 feet. Now that we have that, we can go ahead and solve for our surf similarity parameter. So if we look at the equation for that, it's the tangent of the beach slope times the deep water wave height over deep water wavelength, all to the negative 1/2 power. So we can go ahead and plug in tangent of 10 degrees times 3 feet over 184.5 feet, all to the negative 1/2 power, and we get 1.38. So then for the classification of the breaker, we can go ahead and look at our table, and we can see that when the surf similarity parameter is greater than 0.5 but less than 3.3, we have a plunging breaker. Now the last thing to pay attention to is, for this problem, we're talking about classifying the breaker, right? So previously we've done problems where we classify the wave. So when we're classifying waves, we're determining between deep water waves, transitional waves, and shallow water waves. When we're classifying the breaker, that's when we're classifying between surging, spilling, and plunging, right? So you got to pay attention to what the problem is asking you for, because it could ask you to classify the wave, or it could ask you to classify the breaker, and for those you have to calculate different things. So just pay attention, make sure you're answering what the question is asking to make sure you can get it right.